Welcome to Cooking with Chemists. Today we'll be making apple cake. Let's get started!
The ingredients you will need for this recipe are eggs, sugar, cinnamon, vegetable oil, flour, 6 chopped apples, baking soda, and baking powder. Preheat oven to 350 degrees. First, crack 2 eggs into a large bowl. When we use a whisk or other utensil to beat the eggs, we see a physical change because the appearance has changed, but it is still the same substance it was before it was beaten. Whisking adds air into the mixture, acting as a solute. Eggs are composed of dozens of different kinds of proteins. The proteins in egg look like coiled up balls of string. When they're exposed to heat energy in the baking process, the protein strings unfold and get tangled up with each other. This linked structure makes the runny egg nearly solid, giving body to a spongy cake and keeping it from collapsing.
Next, we will add 1 3/4 cups of sugar. Sugar helps create a web-like structure that traps water and provides moisture. Sugar helps slow the cake from hardening. When a cake begins to go stale, the starch starts to crystallize. Sugar will draw the water and prevent the starch molecules from forming and crystallizing. Sugar is a polar non-electrolyte. Sucrose is quite soluble because its molecules overflow with OH groups. They can come in contact with water, which can form strong hydrogen bonds with water. Sugar can be soluble in water, and therefore sugar fits the like dissolves like rule because both substances are polar.
Next, we will add 2 heaping teaspoons of cinnamon and a half cup of vegetable oil. Oil is an important ingredient in many foods. Molecules of vegetable oils consist of glycerol and fatty acids. Glycerol has 3 carbon atoms and fatty acids have long chains of carbon atoms. The fatty acids in some vegetable oils are saturated and only have single bonds between their carbon atoms. Oil will give the cake a moist, tender texture. Oil and water are immiscible liquids because they do not mix together. For example, if you add oil to water, the oil floats on the surface of the water. Only if you mix the liquids very well, one liquid becomes spread through the other liquid, forming a mixture called an emulsion.
In a separate bowl, we will add 2 cups of flour and 2 teaspoons of baking soda. Wheat flour, which is high in gluten, supports the ingredients during rising and gives the cake its flexibility. When in the oven, the starch portion of the flour gels. With help from sugar, it creates a harder, web-like structure that traps water and provides moisture.
Next, add 2 teaspoons of baking soda. Baking soda, or sodium bicarbonate, has the property of releasing CO2 when it is heated. Here is the equation. Baking soda acts with acid in the batter to create this CO2, adding bubbles to the batter, helping it rise and expand during baking. We will see evidence of this as we cut the spongy cake and see tiny little air bubbles. Pour the apples in the bowl of wet ingredients, coating as you go. Combine all ingredients. Pour mixture into a greased 9 by 13 inch pan. And now, place in the oven for 55 minutes.
There are energy changes that occur in the baking process. Since there is a high temperature when the cake is placed in the oven, chemical reactions occur pretty quickly, since we know that the heat speeds up a reaction. Increasing temperature speeds up kinetic energy, causing more frequent collisions between molecules. Collisions are what cause a chemical reaction to occur, so with more collisions, the reaction rate speeds up. According to the collision theory, the particles must collide in the correct orientation to cause the reaction.
Convection is a process that occurs in the oven. As the heat circulates the oven, it heats up the pan and the cake. Molecules at the bottom of a cooking vessel rise and warm, while cooler and heavier molecules sink. This creates a circulating current that evenly distributes heat throughout the substance being prepared.
Conduction is movement of heat energy through matter by the transfer of vibrational energy between atoms and molecules. We used a metal pan to bake the cake, and this is important because the material used determines how fast the cake will bake, depending on how fast it conducts heat. Thermal conductivity determines how fast the cake will bake because it describes how readily a material will give or take heat through conduction. A material with high thermal conductivity will transfer heat quickly like metals. Heat capacity is another factor, as it refers to how quickly a material's temperature changes with the addition of heat. Metals have a relatively high heat capacity, meaning that their temperature will increase more slowly than others. Overall, metal is a material that conducts heat relatively quicker than others, which is why it is used.
There are chemical changes that occur inside the oven, transforming one substance, batter, into another, cake. This is an endothermic chemical reaction because the batter requires heat to become a cake. The baking process is a chemical change because the finished cake can no longer be changed into its original ingredients.
A few things can happen when you bake a cake. Some chemical reactions to keep in mind while doing this experiment are the Maillard reaction and caramelization. Maillard reactions occur when proteins and sugars are broken down and rearranged by high temperatures. The reactions produced are ring-shaped organic compounds that darken the surface of baking dough. Maillard reactions also produce savory aromas and flavor compounds. Caramelization is the last chemical reaction to occur during the baking process. The reaction occurs when high heat causes sugar molecules to break down and release water, which turns into steam. Diacetyl, which gives caramel its butterscotch flavor, is produced during the first stages of caramelization.
As the cake is baking, there are three chemistry laws that we notice in the process. First off, Boyle's law states as the volume increases, pressure decreases, and vice versa. As more and more carbon dioxide from the baking powder and baking soda is being produced, which is more pressure in the oven is forcing all of the gas molecules to get packed together, reducing their volume.
The next law involved in the baking process is Charles' law. Charles' law states that as temperature increases, volume increases. When you increase the temperature of a fixed number of particles of gas, the particles will move faster. This motion means they will collide more. These collisions are elastic and therefore adjacent molecules will be farther apart, which increases volume. In our case, carbon dioxide gas is produced from baking powder and baking soda. When baked, the carbon dioxide increases in temperature. The carbon dioxide molecules move faster and collide more, thus increasing the distance between them and therefore the volume. The last law involved in the baking process is Gay-Lussac's law. This law states that as temperature increases, pressure increases, and vice versa. When you increase the temperature of a fixed number of particles of gas, the particles will move faster. This motion means they will collide more, as we have discussed before. These collisions are pressure, and therefore it will increase. When baked, the carbon dioxide released from the baking powder or soda increases in temperature. The carbon dioxide molecules move faster, increasing the pressure.